Hi everyone, welcome back to the channel. And today we're going to solve Leetcode daily challenge, problem number 2492, minimum score of a path between two cities. So, it's a really lengthy problem to read, but the crux is very simple. You have to basically find out the smallest number between the paths, among the paths instead, sorry. Okay. So this is what you have to do, and what we'll be doing is we'll first prepare a adjacency matrix in which we will keep all the distance from point A to point B, and after that we will implement DFS on that adjacency matrix. Okay, so and yeah, and to return the answer, we will keep a global variable which will keep the value of the minimum distance we have encountered yet. Okay. So let's move to the coding part directly. I think there is, nothing that needs to be explained. It's a really simple and a pretty straightforward problem. So first things first, I want to define my variable which I'll be returning at the end, and I want to initialize it with infinity, right? And let's just write this way. Okay, done. Next is, I said like we will be preparing a adjacency matrix, right? So uh, adjacency matrix, and I want it to be defaulted with default value of one list. Okay, so here is the point. Like, why are we using self with the adjacency matrix? This is because I don't want to pass in the same variable again and again to the DFS helper function which I'll prepare. So that's why I created this as a class variable. Okay, next. You just have to iterate the roads variable. And with each value, you will get, like in each value of road, you will get source, destination, and distance. Okay. So the the connected edges are bidirectional. So you'll have to add two entries for each value in roads, one from source to destination and destination to source. So self dot. Let me just copy this quickly. Self dot admetrics. From source, I want to append my destination, and it will be a tuple destination and distance. Okay. Similarly, I want to do it the other way around as well. From destination to source with distance, let's say. Okay. This way, we prepared our adjacency matrix. Next comes the part where I want to keep a track of all the nodes I have visited. Okay, so that we just don't end up looping in again and again to the same node. So what I'll be doing is I'll create an array of zeros of exact same length of a number of elements. Okay, and each time we visit a node, let's say we visited node number two, I'll mark the second index element of this visited node as true, as one or two, whatever you say. Okay. Okay. This is done. Next is what? Okay, let's define our DFS helper function now. Okay. So in DFS, I would expect three values. Current node which I want to process, um, let's say min distance, like current min distance, and the visited tuple. Okay, so this is done. Now what? First thing is I want to update the value of my visited array for this particular node. Okay, so visited of node, I'll set it to 1. Okay. Next is what? we prepare this adjacency matrix, right? So what I want to do is I want to traverse, or I want to check all the possible nodes I can visit from this particular source. Like I'll treat this node as my source node. So for like we'll get two values, what? Destination and distance in self dot id matrix, and our source was node. Okay. Now I will update my min distance with whatever. Like if my min distance is minimum or my current distance is minimum, like whatever we have at minimum, we will update our value with that. Okay. Now what? I will check if I have already visited this node or not. Okay. So how will you do that? If not of visited destination. So basically, I'm checking if I have already explored all the ways where my current destination acted as a source. Okay. If not, then what I'll do, I'll update the value of visited and set it to 1. And I will again recursively call the same function. But how will you do that? Yeah, so I'll basically update my min distance value with whatever minimum is among current minimum distance and DFS of destination, like the node will be destination now, current minimum distance, sorry, current minimum distance and visited. Okay. So after all this calculation, whatever you get, you will just simply return that. You just simply return that. Okay, there is just a single thing left. You have to start the DFS. So you start the DFS with node 1. You will pass your min distance as reserved and visited will be visited. And this is it. Like this was a complete code for the problem. Let's check out the test cases. Yeah, so the test cases got clear. Let's submit for further evaluation. And yeah, so the solution got accepted and we performed decent, I would say, like we outperformed 65% of the submitted solution. So yeah, thanks again guys for watching out the video and stay tuned for the following ones. Don't forget to subscribe to the channel. Thank you.